this video, let us see how to find the recurring decimals or how to convert the recurring decimals into fractions. So recurring decimals are those decimals which keeps repeating. The same number keeps on repeating either in pairs or a single digit or maybe as 3 digits. It's not fixed, but the number keeps on repeating. The pattern keeps on repeating, and such decimals are called as recurring decimals. So in case if you see here, 7 over 2 is just 3 over 5. This is not a recurring decimal. But when we come to 2 over 7, it's 0.28. It repeats as 0.285714. And again, it starts as 285,714. So that means that the same numbers, this set of numbers are keeping on repeating again and again. So such decimals we call it as recurring decimals. So let us solve some of the examples with proper steps. So now I have a number here that is 0.6 dot. So what does 0.6 dot mean? It says that the number 6 is the one that is going on repeating many times. It doesn't have an end. The same number keeps on repeating. So either I write it as 0.6 with a dot, or I can write it as 0.6666 continued, which can be showed with this continuous dots. So how do we convert this to a fraction? Let's start with taking x equals to the given question. So in order to have change to a recurring decimals, we should make sure that the decimal point always remains the same. Now this is a simple one. So we have x equals 0.6666 and so on. If I am going to multiply this by a 10x, then this becomes 6.6666 and so on. So we can see here the decimal part is same. Either you have a 3x here or a 4x, it doesn't matter because 6 is keeping on repeating, right? So we can see the decimal part is same. So I'll take this equation as equation 1 and this equation as equation 2. I repeat again, the decimal part need to be the same. So the next step is equation 2 minus of equation 1. So we'll subtract the right hand part or left hand part and we'll equate it to the right hand side. So equation 2 minus equation 1. Equation 2 I have 10x. Subtract the equation 1, that is x, equal to, now this value, that is 6.6. Since there are many x, I'll just put it as 6 dot minus 0.6 dot. So 10x minus x is nothing but 9x. That's equal to, so 6 dot gets cancelled, that is subtracted, and we are left with only 6. So what will be x value now? Since 9 and x are multiplied, it becomes division. So x will be equal to 2 over 3, right? And this is how we can write a recurring decimal as a fraction. So now if you put 2 over 3 in your calculator, you are going to get the answer as 0.66666. Okay, let's say another example. Here is another number. This was single digit, but here you can find there are 2 digits where 5 doesn't have a dot but 3 has a dot. So how can you write this? We can write this as x equals 0.5. I'm not going to repeat 3 because 5, I'm not going to repeat 5 because 5 doesn't have a dot on the top. It's only 3. So it is written as 0.5333, which is 3 is a recurring. Okay. So I'll start with again, let x is equal to 0.5333, or else I can just write it as x equals 0.53 with the dot. Take the given equation as equation 1 and always multiply it by by 10. So when I multiply by 10, the value of 0.53 changes to 5.3 with the dot. Now we have two equations. Just check if the decimal parts are same. Here the decimal says 5.3 and here it says only 3. So they are not same. So we are going to have another equation where we multiply it by 100. So x multiplied by 100 will be 100x and 0.53 dot will change to 5, 3, and since the 3 is recurring, we can have one more 3, right? Now we have 3 equations. So now it's your choice which equations you're going to choose. But the thing is, the decimal part need to be same. Here the decimal part is 5, 3 dot. Here it's only 3 dot. Here it's only 3 dot. So we can say that the second and third equations are the best one to be using. So I'll change the equation 1. This won't be equation 1. We'll consider this as equation 1 because this has a decimal part same, and also this has the second one. So if I subtract 2 from 1, always the bigger equation, bigger number minus the smaller number. So this will give me the left hand side 100x minus 10x, that is equal to, here it is 53.3 dot minus 5.3 dot, that is 3 recurring. So the decimal part is same, so they get cancelled. Meanwhile 100x minus 10x is 90x, that is equal to 53 minus of 5. Now we have a 90x, and that is equal to 53 minus 5, so that will be 48, and so x will be equal to 48 over 90. So this can be further simplified by 2. 2 times 2 is 4, 2 times 4 is 8, 2 times 4 is 8, and 2 times 5 is 10. Again it can be divisible by 3. 3 times 8 is 24, and 3 times 1 is 3. 3 times 5 is 15. So I get it as 8 over 15 in the simplified form. So x will be equal to 8 over 15. Now again if I put 8 over 15 in the calculator, I need to get 0.533333. So this is how you are going to convert any recurring decimal into fractions. Let's say another example. So here I can write x as 0.7 dot 2 dot, that means 7 is also repeating, 2 is also repeating, that is 0.727272 and so on, right? Not 72222, it is 7 and 2 both repeating one after the other. So now let's start with, let x is equal to 0.7 dot 2 dot. If I multiply by 10, it becomes 7.2 dot 7 dot. So now the decimal part is not same. I multiply by 100x, and that will be 7.2 dot 2 dot. That is 7 recurring, 2 recurring. Now if you see the equations, this equation and this equation has the same decimal part. So I'll mention this as 1 and 2, but this cannot be taken since the decimal is 27 here, where I need 72. Now again the bigger equation is equation 2 minus equation 1. 100x minus of x, that is equal to 72.7 dot 2 dot minus 0.7 recurring, 2 recurring. 100x minus x is 99x, and that is equal to, the decimal part is same, so that gets cancelled. So I have 72 minus 0, that will be 72. X will be equal to 72 over 99. So since if we add the numbers 7 and 2, it is 9, and this is 9 plus 9, 18. As it is a multiple of 3, we can cancel it. 3 times 2 is 6, and 3 times 4 is 12. 3 times 3 is 9, 3 times 3 is 9. So again it's a 6 and that's 6. So again a multiple of 3. 3 times 7 is 21, 3 times 8 is 24, 3 times 1 and 3 times 1. So it is 8 over 11. So always make sure that once you finish solving a recurring decimal into a fraction, you put the fraction in the calculator and check if you're getting the same number back. So that is how we can verify if our working is correct. So we get, when you put 8 over 11 in the calculator, we get 0.727272. So the answer is correct. Now we'll solve the next one. So this number can be also written as 0 point. See, you can see that 4 and 9 has the dot on it. So 7 doesn't have. That means, it doesn't mean that 7 is not recurring. 7 also recurs. The meaning here is, if you have dot on the first and the last one and the middle number doesn't have, that means all the three numbers are recurring, it's not required to put a dot on the middle number. So this will be 479, which again starts with 4, again a 7 and a 9, again 4, 7 and a 9, and goes on continuing. So let's see how to solve this. Again, let x is equal to 0.4 dot 7. Yeah. Now let's see by multiplying 10. 10x will be 4.7 dot. It's good that I put a dot on each of the number so that to avoid confusion. So let it as 7, 9, and you know that after 9 again 4 is coming, so I'll write here 4 dot. Yes. So again you can see here starts from 4, here starts from 7, so it's not the same number, decimal part. So again it is 4, 7 dot 9, 4, 7, all three with a dot. Again the values are not same after decimal point. So I take a 1000x, that is equal to 479.4 dot 7 dot 9 dot. So you can see now this equation and this equation has a same decimal part. So it is 2 minus 1. So I get 100,000x minus of nx, that's equal to 479 minus. So again I tell you that the decimal parts are same, so you need to write it again. I'll just write the whole number, that is 479 from here and a 0 from there. So 1000 minus x is 999x is equal to 479, and so when you solve this, x is equal to 479 by 999. So if you want you can solve this further, or this is a fraction. So 479 can be solved as, so we'll better keep it as it is. This is a fraction. If it is possible to simplify, you can simplify. Since it's not possible to simplify by 9, by 3 and 2, neither 5, we can better keep it as it is. And if you put this in the calculator, you're going to get the same numbers. Let's go to another question. The question here is x5 is equal to 0.328. So again, this can be written as 0.328. So here you can see dot is only on 2, 3 and 2. So only, 2 and 8. That means only 2 and 8 are repeating. 3 is not going to repeat. So write it as 3, 2, 8, 2, 8, 2, 8, and so on. If you have confusion like which numbers are repeating, you can try it with many different fractions and check what exactly is recurring decimals. So now x is equal to 0.32 dot 8 dot. Let me multiply by x. It becomes 3 dot 2 dot 8 dot, where 2 and 8 are recurring. If I multiply by 100x, I get 3, 2 dot 8 is repeating, 2 is again repeating. So again check the decimal parts, it's not the same. So I multiply by again 1000x, that gives 328 dot 2 dot 8 dot. If you're having confusion by putting a dot on the top, you can just write the numbers normally as I've written here and then try it so that you're going to have it correctly. Now you can see this equation, and this equation has the same decimal part. I'm speaking about these things. These are the same. So equation 2 minus equation 1, that is 1000x minus of 10x is equal to, decimal parts are same, will get subtracted with 3 to 8 minus of 3. So 1000 minus 10 is 990x, that is equal to 328 minus 3 is 325. So x will be equal to 325 divided by 990. And if you simplify this further, you can see in the last digit is a multiple of 5. So we can divide this as 5. 5 6 is 30 and 5 5 is 25. 5 times 1, 5 9 is 45. 5 8 is 40. So we get here 65 over 198. So you can keep it as it is. So all the answers that we have got are proper fractions. So no need to convert to mixed fraction. 198. If possible to simplify further, you can simplify that, or else you can keep it as it is. Just checking if it can be divisible by 13. It's not. So we'll just keep it as it is. So my final answer for this one will be 65 over 198. So the main thing to be remembered while solving a recurring decimal is that each time you go on multiplying 10, 100, 1000 to the x, and you see that the decimal part should be the same. The numbers after the decimal point should be same. Only those two equations can be taken and solved as equation 1 and 2. And then you get the answer. Thanks for watching. Please comment for more videos.